Imagine you're standing outside on a perfectly ordinary night. The air is cool. The stars shine quietly above you. Nothing feels unusual. But somewhere, 10,000 light-years away, a massive star has already died. In its final moments, it collapsed into itself and unleashed the most powerful explosion the universe can create. A narrow beam of pure gamma radiation is now racing through space at the speed of light. It's aimed directly at Earth. And you have absolutely no warning. You won't hear it. You won't feel it. You won't even see it coming. 1 second, people are looking up at a peaceful sky. The next, an invisible wave of energy has already slammed into our planet. By the time scientists realize what's happening, it's already too late. That's what makes a gamma-ray burst so terrifying. It doesn't arrive with a countdown. It doesn't give humanity a chance to prepare. The light carrying the warning and the disaster itself travel together. When you finally know it's here, you're already inside it. For thousands of years, we've looked at the night sky with wonder. The stars seem calm, almost comforting. Distant galaxies appear as tiny patches of soft light, beautiful and harmless. But appearances can be dangerously misleading. Some of those quiet stars are actually ticking cosmic time bombs. Deep inside them, gravity is slowly winning a battle that has lasted millions of years. When one of these giant stars finally collapses, it doesn't simply fade away. In just a few seconds, it releases more energy than our sun will produce during its entire 10 billion-year lifetime. But the explosion isn't like fireworks spreading in every direction. Instead, it fires two incredibly narrow beams across the galaxy, like the deadliest searchlights ever created. Most of the universe never notices them. But if one of those beams happens to point directly at Earth, even from thousands of light-years away, our planet would suddenly become the target. The scale of a gamma-ray burst is almost impossible to understand. Our brains simply aren't built to imagine numbers this large. In only 10 seconds, a single gamma-ray burst can release more energy than our sun will emit over its entire 10 billion-year lifetime. 10 seconds. That's less time than it takes to read this paragraph. Now imagine one of those explosions happening close enough to matter. Not next door in cosmic terms, but within roughly 6,000 light-years. If its narrow beam happened to be perfectly aligned with Earth, it wouldn't be a close call. It wouldn't be a natural disaster we could recover from. It would be a planetary catastrophe. And here's the part that should make you uncomfortable. There would be no early warning. No emergency broadcast. No countdown clock. Gamma rays travel at the speed of light, which means the first signal announcing the explosion is the explosion itself. The universe gives us exactly 0 seconds to react. When that beam reaches Earth, it doesn't burn cities or blast mountains apart. Instead, it strikes something far more important, our atmosphere. High above the clouds, trillions of gamma-ray photons begin smashing into nitrogen and oxygen molecules. Those molecules are ripped apart in violent chain reactions, producing large amounts of nitrogen oxides. At first, nothing seems different on the ground. People continue driving to work. Birds continue flying. The sky still looks normal. But 30 kilometers overhead, Earth's invisible shield has begun to fail. That shield is the ozone layer. Every day it quietly absorbs most of the sun's dangerous ultraviolet radiation before it reaches the surface. Without it, life on Earth would never have evolved. Yet a nearby gamma-ray burst could destroy nearly half of that protection in a matter of days. The ozone wouldn't recover quickly. Scientists estimate that rebuilding it could take years, perhaps even decades. As the ozone layer continues to disappear, the real disaster begins. Ultraviolet radiation from the sun starts pouring through the atmosphere in levels no modern ecosystem has ever experienced. This isn't the kind of sunlight that gives you a sunburn after a long day at the beach. This is radiation powerful enough to break DNA itself. Every living thing is affected. Plants begin struggling to perform photosynthesis. Forests slow their growth. Crops that feed billions of people suffer severe damage before they can mature. Farmers don't immediately understand what's happening. The weather seems normal, yet harvests become smaller with every season. The oceans face an even greater threat. Near the surface lives microscopic plankton, tiny organisms almost invisible to the human eye. They produce a huge portion of Earth's oxygen and form the foundation of nearly every marine food chain. Under intense ultraviolet radiation, massive populations begin to die. The collapse starts at the bottom. Small fish lose their food source. Larger fish lose theirs. Predators that have ruled the oceans for millions of years suddenly face starvation. Entire ecosystems begin unraveling from the smallest organisms upward. What looks like a problem for microscopic life quietly becomes a crisis for every creature living in the sea. Some scientists believe something remarkably similar may have happened around 445 million years ago during the Ordovician mass extinction. Unlike the asteroid that ended the age of the dinosaurs, this event may have been triggered by something far more distant, a burst of radiation from a dying star thousands of light-years away. No explosion on Earth. No volcanic eruption. Just a beam of light crossing the galaxy and forever changing the history of life. Now imagine that same event happening today. Within months, food supplies begin shrinking. Ocean fisheries collapse. Agriculture struggles under relentless ultraviolet exposure. What makes this scenario even more frightening is that the gamma-ray burst itself isn't the greatest danger. The real danger is how completely unprepared we are. Unlike an asteroid, which astronomers can often detect years before impact, a gamma-ray burst offers virtually no warning. The moment we know it's coming is the exact moment it arrives. Scientists do monitor the universe for these incredible explosions. Space telescopes such as NASA's Fermi Gamma-Ray Space Telescope and the Neil Gehrels Swift Observatory detect gamma-ray bursts on a regular basis. On average, somewhere in the observable universe, about one occurs every day. Fortunately, almost all of them are unimaginably far away and pose no threat to Earth. But the word "almost" carries an unsettling weight. Astronomers know that massive Wolf-Rayet stars, among the most likely candidates to produce long gamma-ray bursts, exist within our own region of the Milky Way. These stars are incredibly hot, unstable, and nearing the ends of their lives. The challenge is that we don't know the exact orientation of every one of them. A star only becomes a direct threat if one of its narrow jets points precisely toward Earth when it dies. And space doesn't provide a map. There is no cosmic warning label telling us which stars deserve our attention. Many remain wrapped in clouds of dust, hundreds or even thousands of light-years away, living out their final centuries in complete silence. Somewhere among them may be a future explosion that will never know our name, never see our planet, and never care whether life exists here at all. If such a burst reached Earth, the consequences wouldn't stop with biology. The intense radiation interacting with our atmosphere could disrupt the ionosphere, the electrically charged layer that allows many communication systems to function. Satellites could experience failures. GPS navigation could become unreliable. Radio communications might break down across entire regions. Now imagine the entire sequence unfolding in real time. A star dies thousands of light-years away. No one on Earth notices. For 10,000 years, a narrow beam of gamma radiation silently crosses the galaxy at the speed of light. It passes star systems, nebulae, and empty stretches of space without slowing down by even a fraction. Then, on one ordinary afternoon, it reaches our planet. There is no explosion in the sky. No deafening sound. No giant fireball racing toward Earth. Instead, an invisible pulse enters our atmosphere. Within seconds, satellites begin experiencing unexplained anomalies. Communication networks become unstable. Scientists around the world receive strange data that doesn't make sense. While experts struggle to understand what they're seeing, the real damage has already begun high above the planet. Days turn into weeks. The ozone layer continues to weaken. Dangerous ultraviolet radiation reaches Earth's surface in increasing amounts. Crops begin failing in different countries for reasons no one can immediately explain. Ocean ecosystems start collapsing from the bottom of the food chain upward. Fish populations decline. Food shortages spread. The atmosphere slowly fills with chemical compounds that tint the sky with an eerie reddish-brown haze. Years pass. The climate begins shifting in unpredictable ways. Some regions become colder as sunlight is partially blocked by atmospheric changes, while radiation levels remain dangerously high. Forests struggle to recover. Agriculture becomes unreliable. Entire species disappear before scientists can fully understand what is happening. No single moment marks the end of civilization. There is no dramatic explosion that history books can point to. Instead, humanity experiences something far more terrifying, a slow unraveling. Every year the planet becomes a little less hospitable than the year before. Every harvest becomes less certain. That may be the most unsettling truth of all. We spend our lives worrying about deadlines, arguments, careers, and the countless problems that fill our everyday world. We build cities, launch spacecraft, and imagine that we're slowly mastering the universe around us. But the cosmos operates on a scale that makes every human achievement seem unimaginably small. Somewhere tonight, another massive star is nearing the end of its life. Somewhere, gravity is quietly crushing a stellar core that has burned for millions of years. Somewhere, the next gamma-ray burst is already inevitable. Whether its beam ever intersects with Earth is determined by nothing more than the angle of a collapsing star and our position in the galaxy at that exact moment. Fortunately, the odds are extremely small. Gamma-ray bursts capable of threatening Earth are believed to be extraordinarily rare, and there is currently no evidence that one is aimed at our planet. Our galaxy is enormous, and most of these explosions occur so far away that they become nothing more than fascinating scientific observations. But unlikely is not the same as impossible. Every day, astronomers continue watching the universe, searching for clues about how these explosions form and how often they occur. Every new telescope reveals that space is even stranger than we imagined. Every discovery reminds us that the night sky isn't just beautiful, it's active, violent, and constantly changing. When you look up at the stars tonight, remember that you're not looking at a frozen ceiling of tiny lights. You're looking into a living universe filled with worlds being born, stars collapsing into black holes, galaxies colliding, and forces powerful enough to reshape entire planets from thousands of light years away. The universe doesn't hate us. It doesn't protect us either. It simply follows the laws of nature with perfect indifference. And perhaps that's the greatest mystery of all.